I'm Michelle Jordan, and today we're going to be doing Eureka Math, Module 2, Lesson 1. Okay, so today on Lesson 1 of Module 2, we're going to look at opposite quantities that combine to make 0. So the first thing we're going to do is we're going to look at what we know about positive and negative numbers. So it says, with your partner, use the graphic organizer below to record what you know about positive and negative numbers. Add or remove statements during the whole class discussion. So if we were in whole class discussion, we would take a minute and work on this individually and then compare notes. But we're going to do this together right now. So thinking about positive numbers. So if you think about a number line, where do you see positive numbers? They occur to the right of 0. They get larger as you move to the right. Some words you might see might be gain, increase, or above sea level. Those are all positive words. There is no sign that is written every time that you see a positive number. If there is no sign, it's assumed to be positive. However, if you want to indicate a sign, a plus sign is indicated sometimes. And positive numbers are the opposite of negatives. All right, so let's talk about negative numbers, and we can kind of mirror off what we said on the right-hand side. So negative numbers occur to the left of 0. They get smaller as you move left. So less value the further left that you go. Some words that are associated would be a loss, a drop, like a drop in temperature, a decrease, or below sea level. They look like things like -7, -12. They have a negative sign. The sign precedes the number, like you see in -7, -12. And so let's put that negative sign there. And they are opposites of positive numbers. Okay, so this being a Venn diagram, so we see characteristics of positives and characteristics of negatives, and then we see the overlap in the middle, and this is what they have in common. So both of these are on a number line. So I'm going to turn my paper sideways. So they are on a number line. Let's look at example number 2. Use the number line below to practice counting up and counting down. Counting up. So when we're counting for a number and we're using a number line, counting up, we start at 0, and that corresponds to positive numbers. So let's take an example. Let's take example of 5. So we're going to start at 0, and we would count up, which means we count to the right direction. So write 5 units. So 1, 2, 3, 4, 5. We see we're at positive 5 here. Counting down starts at 0 and corresponds to negative numbers. So if we are doing from 0 and we are counting down, then we are moving to the left. And let's practice that. So if we had negative 5. Notice the negative sign in front. We would represent that by starting at 0 and counting to the left 5 units. 1, 2, 3, 4, and 5. And we see that we are at negative 5. Where do you begin when locating a number on a number line? You always start when you're locating a number at 0. So start at 0. What do you call the distance between a number and 0? So if we're looking at this, and let's talk about the negative 5. If we start at 0 and we go to the left 5 units, so 1, 2, 3, 4, 5, and we end up at the negative 5 because that's what we represented, it's asking us what is this distance called? So the distance between a number and 0, and that is called the absolute value. You count the units, so there's 1 unit, 2 units, 3 units, 4 units, 5 units. This one, what is the relationship between 7 and negative 7? So if we are going to 7 on our number line, we start at 0 and we go to 7. Let's see how many units we have. 1, 2, 3, 4, 5, 6, 7. So we have 7 units here. Now let's look at negative 7. So again, if I start at 0 and I go to the left 7 units to represent negative 7, that would be 1, 2, 3, 4, 5, 6, 7. So how many units is that? 1, 2, 3, 4, 5, 6, 7. It also has 7 units between negative 7 and 0, and positive 7 had 7 units between 0 and 7. And so relationships between 7 and negative 7. There's a lot of things we could say here, but one of them is they have the same absolute value. That means the distance between that number and 0 is the same. So they have the same absolute value. Let's see if I can zoom out at all. They are both the same distance from 0. They are in opposite directions. So that means that 7 and negative 7 are opposites. So in order for two numbers to be opposite, one has to be positive and one needs to be negative, and they need to have the same absolute value. So another example would be 5 and negative 5, 4 and negative 4, 100 and negative 100. All of those have opposite signs, but the same absolute value. Example number 3. What is the sum of the card values shown? Use the counting on method to provide on the provided number line to justify your answer. So if we were in class, we would be learning how to play an integer card game so we could practice our skills, but we're going to have to do that together on this video. So we're going to start by representing 5. Where do we start on a number line when we want to represent a number? We start at 0. Since this is positive 5, do I want to go in a right or left direction? I want to go in the right direction. So I'm going to start here and I'm going to go right. And I call this bunny hops. You can call it whatever you want to call it. Arrows, vectors, those are all appropriate terms. Bunny hops is easy to remember as well. So most students like bunny hops because it's 1 unit at a time. So 1, 2, 3, 4, 5. So notice with the first number that you represent, you actually end up on that number. That doesn't happen when you start adding all the rest of the numbers because your starting point is no longer 0. Your starting point is where you end up. And so now our starting point is at 5 because we're going to continue to add these integers. So now, since I'm going to represent negative 5, I need to move in a left direction, but I'm starting where I stopped. So I'm starting at 5 and I'm moving left 5 units. So I'm just going to go above where I was. So that's 1, 2, 3, 4, 5. So now I'm here. I'm back to 0. Now I need to represent negative 4, so I'm going to move to the left 4 units. So starting here where I ended up, not because it's at 0, but because it's where I stopped when I went 5 right and then 5 left. Now I'm going to go 4 more left. So 1, 2, 3, 4. So now I'm at negative 4. And now I need to go 8 to the right. Remember, I'm not going back to 0. I'm picking up where I stopped. I stopped at negative 4. So I need to go 8 to the right. So 1, 2, 3, 4, 5, 6, 7, 8. And I end up with my final value at 4. So what is the final position on the number line? 4. What card or combination of cards would you need to get back to 0? So if we are at 4, how many units from 0 is this? Well, it's 1, 2, 3, 4. It is 4 units, or 4 spaces between numbers. So if I wanted to go from 4 and get back to 0, I would have to go 1, 2, 3, 4. So if I wanted one card, I could get a negative 4 and I would get back to 0. Or it says a combination of cards. So we know we need to go left, and in order to go left, we would need some negative numbers. And so a negative 1 and a negative 3 would put us back to 0. I could go 1 to the left, and now 3 to the left, and I'm back at 0. Can you think of any more combinations that we could do to get back to 0? What about negative 2 and negative 2? So back 2, back another 2. There are several other combinations that you can do. Looking at exercise 2, the additive inverse. Use the number line to answer each of the following questions. How far is 7 from 0 and in which direction? Well, since we don't see a negative sign in front, it means that this 7 is positive. So we can count like this. 1, 2, 3, 4, 5, 6, 7. We can see that our absolute value is 7 units to the right because it was positive. Now what is the opposite of 7? So if this is positive 7 and it's 7 units away from 0, we would start at 0, go in the opposite direction 7 units. So 1, 2, 3, 4, 5, 6, 7. So the opposite of positive 7 is negative 7. Just that. How far is negative 7 from 0 and in which direction? So from here, 1, 2, 3, 4, 5, 6, 7 units. And this time, since it's negative, it is in the left direction. Thinking back to our previous work, explain how you would use the counting on method to represent the following. While playing the integer card game, the first card selected is 7, and the second card selected is negative 7. So in this case, we would start at 0, count up 7 to the right, then start counting down, from 7 to 0. So we would start at 0. If we were playing the card game and we were given this card right here, start at 0, we would use our number line and we would go up to the right 7 units. And then if the next card was a negative 7, we would start at 7 because that's where we ended up with our first number, and we would move to the left 7 units and we would get back to 0. What does this tell us about the sum of 7 and its opposite? So sum means to do addition. So 7 plus a negative 7. So if we go to the right 7, and then we go to the left 7, where do we end up? So let's say that again. Let's really listen to the words that we're saying. If we start at 7 and go right 7, and then we go left 7. The word and kind of indicates that sum or addition. So we go to 7, and then we go left 7. We end up at 0. So a number and its opposite equal 0. Look at the curved arrows you drew for 7 and negative 7. What relationship exists between these two arrows that would support your claim about the sum of 7 and negative 7? So if we go back to our number line here, and I'm going to use what they call a vector. So we've done bunny hops, and that's one way you can do it, especially if you feel like you need to count each individual unit. But another way is to just draw a straight arrow or a curved arrow, and we can call those vectors. So if we start at 0, I'm going to make it a little bit longer or taller so that it shows up. And we go to the right 7. So we're representing 7 positive. We stop right there at 7. And now the next thing we need to do is add a negative 7. So if we're adding a negative 7, we need to go to the left 7 units. So we're starting at this point, because that's where we ended up, and we go left 7 units. So that's another way you can represent if you don't want to use bunny hops. So the question was, what relationship exists between these two arrows that would support your claim? Well, if we think about the length of our arrows here, how long is this arrow? Well, it's 7 units. How long is this arrow? It's also 7 units. So the length of the arrows is the same. Do you think this will hold true for a sum of any number and its opposite, and why? I'm going to say it's true. If you start at 0, and move in one direction, and then move the opposite direction, the same amount of units, it'll always take you back to 0. So if you start at 0 and move one direction and then move the opposite direction the same amount of units, it will always take you back to 0. So that's if you're starting at 0. So our property, for every number a, there is a number negative a, so that a plus the negative a will always equal 0. And you can switch that around. You can put negative a plus a equals 0. So the term that we want to talk about today is called additive inverse of a number. A number such that the sum of two numbers is 0. So when we add two numbers together that are opposites, that's called the additive inverse. The opposite of a number satisfies this definition. For example, the opposite of 3 is negative 3. So 3 plus negative 3 equals 0. Hence, negative 3 is the additive inverse of 3. Let's focus on that. Hence, negative 3 is the additive inverse of 3. So we can call it opposite. We can also call it additive inverse. Okay, exercise 3 would be playing the number game and practicing that. We're going to continue on into looking at our problem set on our assessments lesson. If you have questions, please email me.